Let us now look at another problem with the regression loss, which is known as the boundary discontinuity problem. So this is known as the boundary discontinuity problem because the loss becomes discontinuous at the boundary case. To understand this video better, you will need a clear understanding of the OpenCV and long edge definition, which I have covered in detail in a previous video. You can find the link to that video in the description below. So if we consider this red box as the anchor box and the green to be a ground truth box, and if we say that their center points have regress, that is they're coinciding, the width for the ground truth box would be defined as per the OpenCV definition to be this edge, and the height would be this edge, and the angle would say be minus 90 degrees. For the ground truth case, however, the width would be defined to be this edge, the height would be this edge, and the angle is say minus 25 degrees. So intuitively, if we were to consider the anchor to regress to the ground truth, our intuitive solution would be an anticlockwise rotation of the anchor. So if this takes place, the anchor now becomes the prediction box given by the blue box. And what we see when we compare the blue with the green box is that the width and the height have interchanged, right? And if we look at the angle, it went from minus 90, added another minus 25 to become minus 115 degrees. So the difference in angle is now 90 degrees. Although in this case the IOU would be 1, the smooth L1 loss would be large because first of all the width and the height got interchanged, which is called as the exchangeability of edges, and the other is because of the angle difference of 90 degrees, which is known as the periodicity of angle. So in reality, how the regression takes place is by first a clockwise rotation of the anchor to match the angles, which would now become minus 25, and then the width and the height would shrink and extend respectively in order to match the dimensions of the ground truth box. In this case now the IOU would be 1 and smooth L1 loss would be 0. When we look at the same case for the long edge definition, the anchor's width would be defined by the longer edge, the height by this edge, and the angle would be say minus 90 degrees. And for the ground truth case, the width would be the longer edge, the height would be this edge, and the angle would be say plus 65 degrees. Again, the intuitive solution for the regression would be an anti-clockwise rotation of the anchor. And when this takes place, the prediction would be this blue box. And now if we consider these two, that is the prediction and the ground truth, we find that the height and the width are the same. But when we look at the angle, the anchor added say minus 90 degrees, it added another 25, sorry, correction, minus 25 degrees to become minus 115 degrees. That can be seen here. Now, what we see here is that in this case, again, the IOU is almost 1, but the smooth L1 loss is large, not because of exchangeability of edges, but because of periodicity of angle, as the angle difference now has become 180 degrees. So therefore, again, the regression in this takes place by a clockwise rotation of the anchor to match the angles, which results in IOU becoming 1, smooth L1 loss becoming 0. So therefore, what this does is it poses problem during training for the model, and the model ends up learning a very complex form of regression, which creates problem during inference.